Our next speaker this afternoon is David Lukas, professor at Technical University of Liberec, Czech Republic, and he will introduce us to a device for composite nanofiber yarn production using AC needleless and collectorless electrospinning.
Thank you for your introduction. The presentation will be about quite new invention, how to produce unusual material, what is a composite yarn composed of classic core that is wrapped by nanofibers. First of all, I would like to introduce where are we from. We are from the Czech Republic and from the Technical University of Liberec. Our team is composed of people from textile technology, mechanical engineering, and there is also one physicist in this group. What are nanofibers? Nanofibers are extremely tiny fibers. We are able to produce them in the scale of 200 up to 700 nanometers. Here you can compare, for instance, the dimension of a poly from a flower that is called lily with the background that is composed of these nanofibers. I would like also to tell you that the ratio between the man-high and the diameter of the nanofiber is the same as the ratio between the distance from the Earth to the Moon and the height of a man. The ratio is about 10 on the power 7. Here at ITMA, we introduced this very simple method how to wrap a classic fiber by nanofibers. This technology is really something like a harmony between various physical phenomena and engineering that enables the production of this kind of fiber. You can see that people are really, astonished by this quite new technology. And now I would like to tell you something more deeply about what Honza Valtera, who is also here in this room, is showing the auditory during ITMA. So first of all, I would like to tell you that electrospinning is probably the oldest technology by which man-made fibers were produced. First information are from the year 1888. And as a rule, electrospinning runs between two electrodes. One of them is positively charged and negatively charged is so-called counter-electrode. And polymeric solution is transported by Coulomb forces from the positive electrode to the negative. But in our case, the upper electrode is completely missing. And in fact, it has appearance of a shower of nanofibers. That is why this technology could be nicely connected with any other technology where you can wrap a surface of something by nanofibers. And the trick is that we firstly emit positively charged nanofibers, and when they compose a cloud not farther than 3 centimeters from the emitting electrode, then we change the polarity. And that is why this positively charged cloud attracts next emission of nanofibers. So that's the comparison between classic electrospinning on the right with AC, how we call that, alternating current electrospinning on the left. Here you can see that we do not need any orifice. That's in fact the first physical phenomenon that we are using. Jets from polymer are created by self-organization by so-called electrohydrodynamic instability. And these jets are very tiny, and that is why solvent, in the case that we are showing here, it is alcohol, ethyl alcohol, is evaporated intensively And that is why what is the result of this process are tiny nanofibers. Here you can see how it works. First, positive discharge, negative discharge, positive discharge, negative discharge, and so on. The plume of nanofibers, that is the smoke of nanofibers, is carried out or blown away by electric wind that in fact has a direction along this rod-like electrode, and that is why the plume of nanofibers is lifted upwards. Here you can see another trick by which we are wrapping the classic yarn by nanofibers to obtain something like a yarn coated by nanofibers. And it is achieved by just this movement of the classic yarn in the space. We call that ballooning. And it really results in a complete wrapping of a classic yarn by nanofibers. And the result is, in fact, this bobbin made by composite yarn. What are the possible applications of this material that is quite unusual? I would like to show you by several figures from electron scanning microscope. But firstly, you can see the testing line that is here at ITMA to show you how it works. First of all, you can see that AC electrospinning nanofibers are a little bit more fluffy structure compared with classic electrospinning. And also, nanofibers are sometimes a little bit rough. They have no constant radii. And here, what is the most interesting, probably for you, is the cross-section of the composite yarn. You can compare a huge diameters of the filament inside a classic yarn and a very tiny nanofibers that surround it. And here is something like a face view of the yarn, of the composite yarn. What are the polymers we are able to spin? Basically, we are able to spin any soluble polymer. In this case, it is, for instance, polyvinyl butyral, polyamide, what is nylon, polyurethane, polycaprolactone, polyvinyl alcohol, polyethylene oxide, polylactic acid, polyglycolic acid, gelatin, and more others. What is, in our opinion, the best area of application of this new material? That's probably medicine, because nanofibers on the right-hand side resemble a little bit nanofibers in extracellular matrix in our body. For instance, on the left-hand side, that's a courtesy of Professor Schmelzer. These are, in fact, nanofibers in our skin. But in fact, other tissues are also involving these nanofibers. And that is why, for instance, materials for tissue engineering, medical or so-called sutures should be the first products designed from this unusual material. You can see on the left-hand side, for instance, first experiments how cells are growing on the first model of suture braided by this type of nanofibrous composite yarn. And here is the first attempt to produce knitted textile by this technology. On the other hand, I would like to underline that this material has a great disadvantage because nanofibers have very weak mechanical properties, and that is why you are able very easily to damage them on the surface of the yarn. So that is why only if we are able to gently entangle these yarns, when one of the yarn protects another one, then the material is more or less mechanically resistant. So thank you very much for your attention, and if there are any questions, I will be glad to answer you.
Professor Lukas, thank you very much for these very impressive works. Just a little question. I just wonder about the polymer types you tried or you used. I couldn't see acrylonitrile. Did you try it, or was there any specific reason not to include it? It's just my curiosity.
Yeah, we tried it. For instance, we tried to spin it from DMSO, but unfortunately this solvent was not well evaporated, and that is why fibers were a little bit wet. But I would like to underline that maybe within 1 or 2 months it is possible to find some polymeric solution from which nearly any polymer that is soluble we can able to reform into nanofibers. But it is a tricky work, no doubt.
Thank you.
Can this technology apply to natural fiber? Natural fiber?
Natural fibers, if they are soluble, there are some companies that are able even to dissolve silk. Then probably we will be able to carry out some tests how to spin it. Yeah? Or for instance, cellulose is also soluble, but in drastic solutions, and that is why we have to think about how to tell that about our environment, because in fact this technology runs from polymeric solutions. The rest of the solvent is evaporated into the space. That is why we have to think about the green technologies.
If you have time, of course, otherwise we can discuss later on. How do you feed the polymers? You use drums in the system? Perhaps I missed it.
So that's in fact the invention of 2 of our PhD students. The idea is to supply the top of the spinning electrode by a screw pump that is in fact integrated into the system.
Oh, right, just pump.
Yeah.
Thank you.
So, thank you, Mr. Lukas.
Thank you.